Children, having understood the random experiment and events for coin being tossed, several type of examples that we have taken, let's proceed further with another random experiment on dice, its sample space and different kind of events, what we are going to see in this particular slide. So what is the first random experiment? It says, when a die is thrown, you all are aware what a die is, right? So how many numbers can we have in a die? 1 to 6. So when a die is thrown, what is the sample space given by? The sample space is given by S is equals to, we can have 1, 2, 3, 4, 5 and 6. So how many sample points will be there in a sample space when a die is thrown? 6. So what is n of s? N of s is nothing but 6. N of s is nothing but 6. We are going to come across the events also, but let us finish off once again with the second one. What is the second one trying to say? When two dice are thrown simultaneously. Here we had taken one die. Over here, when two die are thrown simultaneously. Children, when two dice are thrown simultaneously, the sample space is given by. It is a bit lengthy, but I want you to understand this. Children, score on the first die could be 1. At the same time, score on the second die also could be 1. So I'll be having 1, 1. I'll be having 1, 1. That's the first answer. Second, score on the first die is 1. That of the second being 2. Likewise, can I have score on the first die being 1 and score on the second die be 3? 1, 4, 1, 5, 1, 6. Children, this is how we can have first line. Likewise, don't you think so that 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6 on the same lines. We are about to get over. I know right now one question is going on in your mind, whether we are supposed to write down all these things in detail in the examination. I am going to answer this. First, let's understand our main concept. Come on, children. So, what did we do so? When two dice are thrown simultaneously, the sample space will be given by S is equals to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Likewise, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Now, if you count the sample points in this, you are going to have sample points as 36. N of S is 36. How many sample points what we have in when two dice are thrown simultaneously? Sample points is what we have is 36. Now the question arises, sir, do we need to write down all these things in detail in the examination? That depends on different boards, but I feel that more or less every board should, except if you write down in this way, maybe they might give you a liberty in writing down 1, 1, 1, 2, dot, 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 1, comma 6, 2, 1, dot, 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 2, comma 6, 3, 1, dot, 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 3, comma 6, likewise 6, 1, dot, 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 6, comma 6, and then writing n of 36. But if you really want to be on a safer side, I would say write down all those sample points. It takes around 30-40 seconds to write down, but you all are safe, right? That you all are sure from your side that nobody can cut your marks. But I feel that most of the board should allow you to write down in this way 1, 1, dot, 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 1, 6, likewise 6, 1 to 6, 6. So n of s is 36. Now this was the sample space when one die is thrown and when two dice are thrown. So sample space of throwing a die is very, very simple. But children, what happens is that there are different kinds of events taking place in these two sums. So let's see one by one what are the different kind of events what we get during the examination. One more thing, whatever events we discuss, there could be more events also. What we are discussing right now are all common events which have come up till now. There can be further few events also. That's what we are going to see in our problems. Whenever we do problems, we are going to see different kind of events which we may not discuss here also. But here, whatever are being discussed are very, very important and basic concepts. Kindly pay attention. When one die is thrown, let A be the event. Let A be the event of getting an odd number. So if I just write down, let A be an event of getting an odd number. Now if I say an odd number, what are the odd numbers over here? 1, 3 and 5, children. So I shall write down A, 1, 3 and 5. These are the sample points in my event A, and if I have to say what is n of A, then n of A is nothing but my 3. What is my n of A? My n of A is nothing but my 3. Let B be the event. Let us take one more event. Let D be the event of getting perfect square. When I say perfect square, what all numbers do you see within the sample space are perfect square? Is 1 a perfect square? Indeed. Is 4 a perfect square? Yes. Children, many children in their haste, they simply write down 4. They forget about 1. 1 is also perfect square of 1. 4 is a perfect square of 2. So what are the sample points which I get over here? 1, 2. What is n of B over here? N of B, number of sample points in event B is nothing but 2. Number of sample points in B is nothing but 2. I'm sorry, it's not 1, 2. It is 1 and 4. 1 being a perfect square, 4 being a perfect square. So 1 is also a perfect square, 4 is also a perfect square. Other than these two, there are no perfect squares available. Let me take an interesting event. Let C be the event. Let C be the event of getting score less than 7. Or for that matter, you can say less than or equal to 6. I repeat, either they say less than 7 or less than or equal to 6. Now when I say less than 7, or I can say less than or equal to, what will be my sample point? When they say less than 7, means 1, 2, 3, 4, 5 and 6. All 6 are going to be there. Let's write down 1, 2, 3, 4, 5 and 6. Even less than or equal to 6. When they say equal to 6, I have to include 6 also. Children, what is my n of C? N of C is nothing but 6. Anybody, those who can recollect my previous videos, can you tell me what kind of event this will be? Yes. If not, then once again, I want you all to refresh your concepts. Go back, watch the basic slide what we have done, the very first introduction. Right over there, I have made you understand this is nothing but, yes, there are many who are right now answering also. This is a sure event. This is a sure event. Indeed, it's a sure event. So this event is termed as a sure event. Let me take one more. Let D be the event. Let D be the event of getting score less than, less than 0. Is it possible? So, sir, everybody knows that this is an impossible event. But how about if I say let D be the event of getting score more than 6? Now, children, again, if I say let D be the event of getting score more than 6, do I have any answer to this? So those who are thinking that, sir, what can we write down in the sample point? Your sample point will be, it will be a null event. It will be a null event. You can also say this is an impossible event. This is an impossible event. What kind of event this is? What kind of event this is? This is an impossible event. So we have a sure event also and we have an impossible event also. D being an example of impossible event. And if somebody has to say what will be the n of D, then n of D is going to be 0. N of D is going to be 0, and such events are termed as impossible events. Children, let's see different cases. Let me just highlight this so that you all remember. That being a sure event, this being an impossible event. Here, many interesting events is what we are going to come across when we say when two dice are thrown simultaneously. When two dice are thrown simultaneously, we have sample space, we have sample points, we have n of s also 36. Let's discuss one by one. Let A be the event. Let A be the event. Let me use this one so that you can distinguish between the first one and the second one. Let A be the event of getting sum of scores. Let A be the event of getting sum of scores on both the dice at the most 4. So let me write down this over here. Sum of scores is at the most 4. Now when we say sum of scores, we have to add scores on both the dice. Indeed we have to. So let's start from the first sample point. What is the first sample point trying to say? 1, 1. So what is the sum of scores? Sum of scores will be 1 plus 1, 2. So I'm just writing over here to make you understand the maximum score what can I have is 2. Sorry, minimum. I'm really sorry. The minimum score one can have is 2. What is the last one? 6, 6. So what is the maximum score one can have is 6 plus 6, 12. 6 plus 6, which is 12. So all the sample points which are there in between, you can say sum of scores of both the die will lie between 2 and 12. Will lie between 2 and 12. Keep this in mind, children. Whenever we have an event which talks about sum of scores, minimum is 2, maximum is 12. One more thing. At times they also talk about product of scores. In that case, product of scores is 1 into 1, 1, and product of scores is 6, 6 are 36. Product the answer is going to be 1 and 36, minimum being 1, maximum 36. Sum of scores, minimum 2, maximum 12. Come back to our event, what we said. Let A be the event where sum of the score is at the most, means maximum to maximum 4. Minimum to minimum we have discussed. Minimum to minimum we have discussed. How much it should be? 2. So what are the numbers whereby which the sum of the scores will be 2 also, 3 also, and at the most 4. So let's start. Is 1 going to lie? Yes. Why? Because sum is going to be 2. So if you want, you can always tell yourself in the rough column that what could be the sum of the scores. Sum of the scores could be 2, sum of the scores could be 3, and sum of the scores should be 4. 1, 2, yes, certainly 1, 2 will give you 3. 1, 2 will give you 3. Is 1, 3 going to be there? Yes. So 1, 3 will be there. 1, 3 will also be there. Is 1, 4 going to be there? No, children. Likewise, I'll discard this. How about 2, 1? Indeed, 2, 1 will give me 3. So 2, 1. How about 2, 2? Indeed, that will also. 2, 2 will also give me. How about 2, 3? It's going to be 5. No. And again I can say if I proceed further, I'm not going to get it. What about 3, 1? Yes, certainly yes. 3, 1. Need not write down the way in which I'm writing. Only thing is what I want to understand is the triangle which is getting formed. The triangle which is getting formed. Sum of the scores is at the most 4. Now should I go beyond this? 3, 2. Sum is going to be 5. No, we cannot get it. So my sample points gets end over here. A is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 1. And my n of A, you can say my n of A is nothing but 1, 2, 3, 4, 5 and 6. My n of A is 6. Let me say B be the event. Let me say B be the event of getting sum of scores Let B be the event of getting sum of scores at least 10. Let B be the event of getting sum of scores at least 10. So let's check what will be the answer. At least means minimum 10. Minimum 10. And what is the maximum? Maximum is what we are aware about. Maximum could be 12. So what will be the answer? If you want, you can write down what could be the numbers which can, what are the sums which can come over here. 10 can come, 11 can come, 12 can come. So how can one start with 10? Children, those who think that very first answer which comes in your mind is 5, 5. Very first answer which comes in everybody's mind is 5, 5. But children, 10 is what we obtain by, not first by 5, 5. The very first thing is what it comes is 4, 6. So when I say here 4, 6 can give me 10. You can say 5, 5 can also give me 10. Children, let's finish off in understanding that how many numbers can give us 10. Sum as 10. So 4, 6 is what can give me 10. 5 can give me 10. Even 6, 4 can also give me 10, mind you. So can I say 6, 4 over here? 6, 4 can also give me 10. Now, is there any further permutation combination which can give me 10? No. 4, 6, 10. 5, 5, 10. 6, 4, 10. Now, let's switch over to the 11th one. How 11 can be obtained? 11 can be obtained by saying 6, 5. 6, 5. Likewise, 5, 6 also. Acha. Now, if the question arises that is there any necessary to write down all the sample points in an order wise? No. It is very much not needed that it should be in order wise. You can write down in any haphazard manner you want, but you should not miss out any. Are we done with 11? What is left? What is left is 12. How can we get 12 as sum of scores? 6, 6. As we have discussed earlier, minimum 2, maximum 12. So, which is the sample point which can give us maximum score 12? Answer is 6, 6. So, children, what is n of b? For my event to be sum of scores, it be at least 10. My n of b shall be 1, 2, 3, 4, 5 and 6. My n of b is 6. Now comes very, very interesting, children. Now comes very, very interesting. Let C be the event. Let C be the event of getting score on second die greater than 1. Sorry, greater than first. Let me say greater than first. Let C be the event of getting score on the second die greater than first. Now, we have the entire sample space with us. Let me just erase this so that you will be able to understand. This was for the previous event. Let C be the event of getting score on the second die, mind you, greater than that of the first. Is this? No. 1, 1, both are the same. How about 1, 2? Yes, the score on the second die is greater than that of the first. 3, 1, that is 1, 3, the score on the second die is greater than first. Children, likewise, if you just happen to check, I am making this triangle only for you people to understand. This is what the answer will be. If you look into this particular triangle, at every place you are going to find the score on the second die is going to be greater than that of the first. Check it out, children, check it out. Right? Likewise, let me give you again D being the event. Let D be the event where the score, D be the event of getting score on first die greater than second. Now in that case, I know I have not answered this also. I'm yet to answer D also. But in that case, children, score on the first die greater than the second. This will be missed out. But 2, 1, yes. 3, 2, yes. 3, 1, yes. So children, don't you think so that This is what the answer will be. This is what the answer is going to be. And lastly, what I want to say, let E be the event of getting score on both the die same. Both the die same. Or at times they use the word doublet. Doublet means you have the same score. At times they use the word doublet, means same score. Children, this is what I want you to understand. The diagonal part. The diagonal part. So I won't be writing right now. You can write down the sample points over here. In each and every event you will write down the sample points as I have marked. Here also as I have marked, and here also. I shall just write down what is n of c, children. N of c is going to be, if you count, this is going to be 15. This is going to be 15. What is n of d then? N of d likewise. N of d is also going to be 15. Lower triangle. N of c, upper triangle. N of d, lower triangle. And score being same, n of e is going to be the diagonal across. If we had a rectangle, this is the diagonal across, and n of e is going to be 6. So let's calculate whether we are right or wrong. Score on the second die greater than that of the first one, we have 15, upper triangle. Score of getting score on the first die greater than that of the second one, lower triangle. Again, it's going to be 15, and score on both the die happens to be the same. It's diagonal what we are talking about. Answer is 6. 15 plus 15, 30 plus 6, 36. That's what our sample space is. Children, this is what I was talking about. This is really interesting when it comes to C, D, and E. Once again, I want you to refresh all the events. And one more thing is what I forgot to tell you earlier on, is that in the previous one, when we had given you the random experiment of coin being tossed, I gave you the formula over there. The formula was 2 raised to n, right? We have a formula for sample space for random experiment of die also, and the formula I'll just write down over here. The formula is 6 raised to n. The formula is 6 raised to n. Now you can just check it out. If one die is thrown, the number of sample points in that particular answer will be 6 raised to 1, 6. If there are 2 dice being thrown, then 6 square, 36. If there are 2 dice being thrown, 6 square, 36. So general formula, in the coin case, it was 2 raised to n. In the case of die, it's going to be 6 raised to n. Children, I want you to understand all the events which I have given you, along with the random experiment of a single die being thrown and 2 dice are thrown simultaneously. When you remember all these things, your problem becomes very, very easy.